So many good speakers in so little time. Our next speaker is Eigil Friis Christionson. He's served as director of the National Space Institute since 1997. In 2007, the institute became part of the Technical University of Denmark. He has served in various capacities at the Danish Meteorological Institute, at the Niels Bohr Institute of the University of Copenhagen, and at the European Space Agency. He's the author of many papers and invited to contribute to many conferences. So help me welcome Eigil.
Thank you, and thanks to the Heartland Institute to inviting me here, and thank you for coming and listening to my reflections. During the last 20 years or so, I have been involved in this kind of business. I have divided my talk into these different issues, as you can see. Mainly it's because I have been concerned about the way that the science process, the science methodology, is being conducted during a landscape of a very clear political agendas. So my motivation is that I have always been of the meaning that the scientific process, the scientific method, would survive any attacks, because that we have been experiences during the modern science period, and I think the modern science started about the time of the Renaissance, and I'll come back to that. But when I saw that Al Gore was awarded the Nobel Prize, then I got quite concerned, not because he got the prize maybe, but because the media immediately used it as a kind of a confirmation that those who run the models, the climate models, were true, and everybody else was wrong. It was said the debate is over, and it was said over and over again. But I think we as scientists, and I have been working as a scientist until I got the director of the National Space Institute, where we have other objectives, of course, but one of the objectives of a space institute is, of course, to make experiments, to make observations, because that's the only way to find out what is wrong and what is right. So we should not, as scientists, be those that confuse politics and science. And I think the debate is important. As long as advancement of science is going to continue, then we need to debate over and over again. So, modern science. What characterizes modern science? I think many of you would say computer simulations if you're talking about modern science just as the last 20 years of science or so. And that's true that computer simulations is a big part of modern science, maybe too big. But I would like to refer to three Danish people that have influenced science as we know it today. One of the fundamental pillars of modern science is observations. And in this respect, many regard the Danish astronomer Tycho Brahe as the father of modern science, because his extremely accurate observations made it possible to formulate some of the fundamental laws of physics on which our society is based. I think that was the first time that you really could take advantage of very, very precise measurements and quantify what you saw, and not just making speculations. Another great Dane was Nicolaus Stenius. He may be regarded as one of the fathers of modern geological sciences, because he observed fossils in high mountain areas, and this convinced him to go against the mainstream doctrines of the evolution of the Earth that at that time was based on pure speculations, also religion or religious speculations. And then the last that I will mention in this context here is Hans Christian Ørsted, who discovered electromagnetism by doing experiments. Nobody else really had thought about this connection, because, and as Ampere wrote to a friend, the French scientists, which were, dominating the physics in those days, did not discover electromagnetism 30 years earlier as they could have done, because Coulomb had stated that there could be no connection at all between electric and magnetic phenomena. So that tells us something about not believing in authority, and I think today's authority is perhaps consensus. That's at least what we, or many of us, feel. But there are, of course, others that can see through this consensus and find out what is really true and what is wrong. Faraday appreciated the way that Hans Christian Ørsted pursued his idea by making experiments instead of just believing in authority. I don't think it's necessary in this audience here to remind us all about the scientific method. You can read it in the Wikipedia, and I think the fundamental thing is that you propose a hypothesis and then you try to falsify it. That is the way that science should be done. That's the way we have done it for centuries, and I think that's the way we should continue to do it, and we should not be tempted to go into other directions. I think one of the things that also characterizes today's discussion, you could call it this scientific discussion, but it's very much influenced also by distinguishing or not distinguishing between scientific debate and personal attacks. I think when I was asked to give this paper in October, I think I got the invitation. That was before the climate gate was revealed. I think now it is very clear that there's a lot of things behind the curtains that influence the way that people think, the way that people attack each other. And one example of this is an analysis that was put into the real climate in November, just before the summit in Copenhagen, where Peter Laut, he is a previous advisor of the Danish government regarding energy and climate questions, he thought that he needed to discredit the Danish scientists, in particular Henrik Svensmark, who is here in the audience also, regarding some of the really new discoveries about the relationship between cosmic rays and cloud formation. But he did not only criticize it, it was his aim to go back to two papers from 1997 and 98. Although they are outdated, although science has progressed much further, he felt it important to go back and discuss these, of course, with the intention to discredit not the science, but the person behind the science. And he went very far, because you can see two figures from two publications in those days. They are very similar, but they're not similar because you can see from the scale that they represent different data, but he didn't realize that. So he thought that these points with the red frame were points that had been removed in the second paper because they didn't fit to the data. And he stated that in Real Climate, and the Swedish television took it up and made a documentary where they pursued this issue. And it took me half a year after I filed a complaint there until just last week, a press release from May the 3rd, the Swedish television was criticized by the Swedish Broadcasting Commission. It shows that there is some fairness at all in the system, but you should also know that out of I think 7 members, there was one member that didn't want to discredit the Swedish television. That was a former minister in the previous government, Swedish government. So, but this was taken up also by Stephen Connor from The Independent. And I was quite amazed that a journalist from another country takes this issue up because these things concern papers, initial research that was done between 15 and 20 years ago. Why is that so important to take it up today? Well, it has something to do with not the science, but to do with discrediting persons. because that, if you can discredit a person, then he will not be credible in society. And he wrote a paper there just during the Copenhagen summit and said that 6 leading experts, including 1 Nobel laureate, agreed with Laut's analysis that the graphs of Friis, Christionson, and Svensmark showing apparent correlations between global warming, sunspot, and cosmic rays were deeply flawed. But then he goes further on saying, Friis Christionson now accepts, without saying now means 10 years ago, when we published another paper where we had new data, which I will come back to later on. But that's the way that the scientific process is described. And another famous person from Britain, so I think he has been mentioned several times at this meeting already, George Bonvio, from The Guardian. He also tries to ridicule the scientific process. And he wrote in The Guardian, that was just after the movie, The Great Global Warming Swindle, that he also thought it necessary to discredit some of the scientists, including me, that were present in that movie. And he went back to one of our earlier papers, a paper from Science from '91. And I have shown the composite graph from that paper here and try to explain to you the difference between the caricature and the logic behind scientific methodology. I mean, the hypothesis is that a solar climate link exists. Then how can we demonstrate that, or how can we falsify that? And I think immediately one could just make a graph, and that's the black curve of the northern hemisphere temperature, the land temperature. That was a temperature record that were considered at that time to be the most reliable temperature record. And then the sunspot number, and that's the blue curve. And that would be a falsification of the hypothesis that there existed links, of course, because the temperature rises before the sunspot or the solar activity measured in terms of the sunspot number rises. But maybe the sunspot number is not the real characteristics of solar activity that has an influence on climate. And therefore, my co-author and I went back and looked, are there other ways of describing solar activity? And we went back into the literature and found out that the solar cycle length, which is normally 11 years but can be shorter or longer, also indicates some fundamental characteristics of solar activity, which was during that time not in phase with the solar activity measured in terms of sunspot numbers. I went back then 400 years and found the same agreement, but it is interesting to note that this interval from 1900 to about 1980, or even less, is the only period where there seems to be a difference in phasing between the sunspot number and the solar cycle length. For all other periods, it would be quite as good to use the sunspot number, but just during that time. And of course, then we also looked, because it was a long filtered data, I will not go into details with that, but we checked it with the recent years using unfiltered data, because we could not filter with a filter of 55 years length, and could confirm that it was still compatible with the hypothesis that there was a warming between 70 and 86, and there was also an increase in solar activity. But the way, you can see it on the right, that Georges Bonvio describes is really a caricature of the scientific process. We did also do, when we got 10 years later, we got newer data, and then we discovered, and also wrote about it, that after 1986, there is a discrepancy. You can see the black curve, the temperature record, as you know, is rising very steeply, and the solar activity starts to, also in terms of the solar cycle length, we now, of course, used a shorter filter, because we need to do that because the solar variability or the solar activity varies with a shorter time scale, then we cannot use a long filter, of course. So now we admitted at that time that after 86 there was no direct correlation between these two figures, which could mean that you could now finally see some influence of the greenhouse effect, but it could also be other natural phenomena, as we have also been witnesses during the last decade, including ocean currents and things like that. And then, of course, the next step, natural step in the scientific methodology is to find out not if there's a correlation, but why is there a correlation? What is the physical mechanism? And we had a hypothesis in the beginning that my colleague Henrik Svensmark promoted, that the total cloud cover could be influenced because that would give an effect. It was turned out then we could not falsify it for the years 82 to 95, which were in agreement. When we took more data, then it showed up that it was only the low clouds that were affected, and that makes sense because there are two different physical mechanisms involved. And that hypothesis has not been falsified yet. But you can see on the right the way that George Monbiot describes this and ridicules completely the scientific process. So now, of course, the next step, of course, is now or was at that time more to find out the different issues connected with the physical mechanism. We could do that by experiments, we could do that by more correlation, we could do testing in a laboratory, for example, and also in nature with shorter timescales. And all that has not been able, all these things have not been able to falsify the hypothesis that cosmic rays have an influence on cloud cover. So the peer review process is another thing, and I think the ClimateGate has shown some of the problems there. But one particular referee report I found really disgusting when my colleague got it, and you can see here that the referee writes, unlike the CO2 warming theory, which agrees with every plausible computer models of climate has been tested, the author cites no climate model evidence to support his claims. And then he said, I found a more extensive critique of this point at Real Climate, or that I guess you know. It was from a person called himself Gavin. Maybe you can guess who that could be. But then he explains all the steps that would be necessary to prove that the hypothesis is true. But science methods is not about proving. It's about falsifying. And science goes not to do with one glamorous theory at one time, which is either wrong or false. It goes by taking small steps, and every step you have to go through this test and find out if it's right or not. So what he said that, in reality he said, I have no more comments, I can just refer to Real Climate and this thing here, and since the author has not argued against these claims in Real Climate on the web, I propose that or I recommend that the paper is rejected. And that is the process in a very respected journal that I'm quoting here. So, I think my time is about out, but I'll just finish with my conclusions. That, of course, this political agenda has influenced the more normal scientific debate. I come from my scientific field is solar, wind, and magnetosphere interaction and ionosphere interaction, and I only, as a side business, went into this part. But it was very obvious that coming from one climate or one science community to this science community is really a big difference. And the difference is, of course, the political background. So it seems, as you could see from the referee's report here, that the scientific methodology is about forgotten. So I will leave it here, these conclusions here, and thank you very much for listening. Thank you.